Okay. I think it seemed like most were done or pretty close to done, or maybe if some, I don't know, a few students were stuck, which is understandable because this stuff is not super obvious or not super intuitive. So let's maybe now we'll go over it and then talk about question number two also. It's a good question, but it's not clear what they're asking, and I don't know how do they want you to answer. So the first they asked the probability of antigens present here. It's the same as the last one. They said you have a 20% chance of having this virus in this region anyway. But the probability, the second one, probability of a positive test result, given that you have no antigens, that's a false positive. And what they say that was 5.9%. So in decimal form, 0.059. And then the negative test result, the probability of a negative test result, given you do have antigens, that's a negative, false negative, and that was 2%, or in decimal form, 0.02.
I think that confused some people because I don't think they thought that was a question. So they just went straight down.
Hey, that's okay. You know what? That's fine. You know, if you didn't fill those in, but you got the table right, then that's fine. I think filling those in is supposed to just help you get to the.
Yeah, that's why I was telling, some of them that, needed a little bit of help. I'm like, I always fill out everything so I could go back to check.
Right. That's a good idea.
I was like, but we were supposed to fill out the top. I was like, it makes it easier that you're using the numbers.
Yeah, I think if you didn't fill it out, that probably means this is not that hard for you and you just skip it, and that's okay. But what did we fill in first in the last table? I think we filled in the very rightmost column. So what is it should be the top number in that rightmost column is 20% of the 1,000. So it should be the same number, right?
The 200 was it?
Yeah, and that's only because it comes from the first probability, 20% of 1,000. So that's why it's the same number, 20% of, and they made the total the same, 1,000. If it was a different number, then maybe that 200 would be something else, but the total number of people was the same and the percentage of people that had the virus is the same. So that means that the number of people that don't have the virus should be the same also, 800. So that last column is the same. It's just the other numbers that are going to be a little different based on the false positive and false negative numbers. So how about the false, and then what did we fill in next? And the last one, what was number 3? Just you don't have to fill necessarily fill in the same order.
I did the 0.02 of the 200 infected, and I got 4.
Yeah, okay, good idea. 0.02 times the 200. That would be the number of people that got a false negative. Yeah. So they go here, and you get 4. Yeah, you're right. That's why like I said, that's why they pick 1,000 as the total, even though there may be not 1,000 people, there might be more or less, but it's just a nice round number. So out of 1,000, 4 would have a false negative and yada, yada, yada. And now that you know that one, you could probably fill in the one to the left of that because whatever plus 4 should add up to 200. So what'd you get?
196.
Yeah, there you go. 196 should go here. Nice. I think the other one was it 197? It was almost the same, huh? Very close.
Yeah, that they were only one off.
Yeah, kind of interesting. So that fourth box, I think we're trying to fill it in the same order. Although if you feel comfortable with this stuff, you could fill it in a different order.
It's for it because when I always write everything down too.
It kind of depends if you how comfortable you feel. We just focused on the false negative first and then the false positive, but you could have easily looked at the false positive percent first and then the false negative. So don't feel like you have to do it in this order. I know this will work, which is why I'll just keep doing it this way if it'll work. And then I think the next thing was the false positives, right? Yeah. If you get
which was the 5.9% into decimal was the 0.059 of 800, which was, I always use decimals, so I got 47.2.
Nice 47.2. So kind of like on the last table, if you write that exact with the decimal, then that's fine, but if you want to round it to the whole number, that's fine too. 47, yeah, totally up to you. It kind of depends how you feel about it.
And then I subtracted it from the 800.
Nice. There you go. So this missing number here should be 8 because the total, yeah, like we said, each row should, every cell should add up to the very rightmost cell. So 47 plus what we're missing there, question mark, should be 800. That means that question mark thing that we don't know, the empty cell there should be 800 minus 47. So that's like this, I guess, the 6th thing we're filling in. Oops. What the heck? Oh, geez. I say what the heck too much. My little 3-year-old, now he says, what heck? I'm like, oh, I should probably stop saying that.
It's okay. When my son was little, when I was upset, I always used to say, "You're fired." And if he'd get upset, he'd tell people, "You're fired." At
That's
least
cute.
that's a little bit better, but they would laugh. They're like, "I've never heard a kid say you're fired." But that's what I had to use, instead of something else. They're like, "I've
Yeah,
never heard you say that." I was like, "Yeah." I was like, he knew when I was upset. And then he started saying it. He started telling people when he was upset. He's like, "You're fired."
that's cute. That's a cute thing to say.
Yeah. I was like, yeah, I work with kids. I love them. I had to try to find something,
Yeah,
something doable, because then the teachers start looking at you because they're like, they know they get it from their parents or whatever is going on at home.
that's true. I know. That's why I should stop saying bad words probably. Oh, oh well.
Yeah. Hey, they're going to hear them at school anyways.
There you go. Your teachers heard it before. It won't be a shock. Let's say. Yeah.
Right?
No, I'm just kidding. That's a bad way to think of it.
No,
Uh,
it's not, because you can't shelter them forever. Other kids will say,
so so the bottom two cells that we don't know, this is almost like now you're rounding the bases in baseball. I don't know, like you've already hit a home run, you're gonna make it. I'm just gonna run slowly and just wave at everybody in the stands like, I did the hard part, now it's the easy part. I'm just gonna add vertically. The 196 and the 47 should be 243. Wait, is that right? I think so. Okay. And then adding vertically, they're the one that's just 4 plus 753, so 757. Yeah, and you can always check your math by adding, those two blue numbers I just wrote should add up to 1,000, and then I shouldn't, that somehow all of my writing moved up when it shouldn't have. I don't know what the heck. It's 200 and 800, of course, should add up to 1,000, but I think those look good. So which of the numbers we were looking for in this? They wanted to know what's the probability that someone has antigens given that they got a positive test result. So I got a positive test result. What's the probability that I actually
the
got-
196.
Yeah.
Right?
And I don't know. Now I can't remember if we did it. Did I actually write a fraction for probability in the last one? In the first
No.
page? Oh, geez. Probability should be a fraction. Oh my gosh, come on. Oh, geez. Now this is the hard part. Okay. The probability that someone had antigens given that they had a positive test result. So it's a conditional probability. What should be my denominator? Is it the total number of people or only those who had a positive test result? What do you think? 1,000 or 243?
What was the question? How did you make?
Just in regular probability, not this one's conditional, but in regular probability, the denominator is supposed to be the total number of people. But in this one, am I using the total or just that part, the positive test result people?
I would just assume the positive test result.
Yeah, exactly. And I see in the chat, Joey said the 243. Yep, that's it. So I think we said that on Tuesday, but it's probably worth saying again. Conditional probability, these ones that have the given that vertical bar inside of them, the denominator won't be the total number of people, the total number of whatever you're looking at in the problem, but just that part, the people or the things that are in this category, that rightmost thing that comes after the given that. There are 243 people that had a positive test result. 196 of them actually had the antigens, so that would be your probability. Let's see, what would that be as a decimal? Because I mean that's a fine answer, but just because I know in number 2 we're going to be comparing number 1's answer and then number 2 or page 1's answer and page 2's answer. It's about 0.8. That's about 80%, 0.81, I guess. So 81%. Yeah, 81%. So of those tests, of the people that tested positive, only 81% of them actually had COVID. So 19% of the people that test positive don't have COVID. What the heck? That's kind of a bummer. Okay. I think now maybe I'll look. I don't know why I didn't do the percentage in the last one, or the denominator. Same thing here, but now the denominator should be again the number of people that tested positive. Yeah, the number of people that tested positive in the first page was a bigger number down here. The total number of people that tested positive 320, so it should be 197 over 320.
So the percentage that we get tested positive, is that what you're saying?
Yeah, because I forgot. I don't know why I would put just the number. It's not just the number.
You're over here confusing me.
It's a probability. Yeah, probability should be a fraction or a decimal, not just a number. I put the numerator, but I never put the denominator like a silly.
Yeah.
Person. Oh my gosh, should be well. I got 0.616, so about 62%.
Yeah.
So now
I just put 62 and I rounded the.
Yeah.
And so those are the people that didn't have it.
They
did.
They had the probability that they had it, given that they got a positive test result. sometimes you wonder that, you take a COVID test, if you got a positive test result, you just assume, yeah, okay, I must have the virus. But actually, in this case, only 62% of those that tested positive actually had the virus. That's nuts. That can't be right. That's crazy. Okay, calm down. Just relax. And then with the other test, though, 81% of the people that tested positive actually had the virus. That's a big difference. Right? Yeah. So if you took, this is only, now this percentage is not for people in general. This is just for people that tested positive. If you took the tests, this is the one that was the Binax or Binax, whatever. If you took that test, you got a positive test result. 62% of the time you actually had the virus, but the other percent of the time the people didn't have the virus. What the heck? But in the second one, with this more expensive one, if you got a positive test result, you had an 81% chance that you actually did have the virus. That's pretty significant difference, 62% versus 81%. So I think the answer to number 2 would probably be, I think you can make an argument either way, honestly. It depends how cheap you are. If you're cheap like me, you say, just buy the cheap test, and then, okay, 62% chance that a positive test result means you actually
I think it's ridiculous because if you don't get to know it right away, you can, like you said, you could be infecting people, period.
Yeah. That's why that thing didn't really.
You have to wait so long. And like we talked about, if my work's paying for it, you guys can go for the most expensive if you want to know right away. I ain't paying it,
Yeah.
And then I also put that it just depends on the person, because some people will go for the most expensive because they think it's the best. It doesn't always mean it's the best, but on here it does, because on the first one, what we got was that the only 38 didn't. And then on the other one, 19 only did it. So if you go by percentages, the second one would be the best, even though it's more expensive.
Yeah, it probably depends. I would say if no matter which side you're on, I would just buy the Binax one because it's cheaper. I don't care if it's not as accurate. Or
it's more like an opinion, unless it's going off of the numbers.
I think if you write it either way, I'm happy with that. It just kind of depends. Yeah, I would say you can make an argument for the Binax one. Say, well, it's pretty accurate. Okay, it's not as it's not as accurate as the other one, but I'm not going to pay $75 for one test. That's crazy. Then I'd say, okay, fine. Depends on how you feel.
Who's paying for it? That's what I was.
That's true. Yeah, you could say, well, the government's paying for it. I don't really give a crap. The ones they send you for free. Right. But if you're having to pay for it out of pocket, it's like.
Yeah, I don't think so.
What's more important to you, I guess? Saving
That's
money.
like half a gas tank in my truck. No thanks.
Yeah. Well, as a group, when you guys were in groups, if you got to number 2, if you finished all the math and stuff, what did you get? What did you say? Did you discuss that one, number 2? Which one would you recommend?
We talked about it when you told us. We did say the same thing. It depends who was paying for it, really.
Yeah. Yeah. That makes sense. I would agree with that. If my
I didn't know about the percentages because if you do it the math way, if they want to know it that way, the second one was better because only 19 didn't get it.
Yeah. Yeah.
So if you go by the percentages, 19 didn't get it with that one, and the first one, what did we get on the first one? 38 did. That's like twice.
Right. Exactly. Yeah.
So if you're going math wise, the second one is better if the money is not a big deal.
Right. Yeah. Some people just have so much money, they don't know what to do with it. Okay. Right. Buy the more expensive one. Okay, whatever. But if you're like, I got to either pay for my car to get fixed or I got to pay for these COVID tests, then you're probably just going to say, I'll buy the cheap ones. It probably depends on where you are. How about any other groups? Did you have a opinion one way or the other? Well, if not, no worries. I would say if you didn't get to this point, then don't worry about it. But you can just kind of.
We kind of thought Binax would be better since it came with 2 and it was cheaper, so you could just use 2 tests.
Yeah, that's kind of what I was thinking too. You're right.
But then the result was that 38%. That's what I'm saying. It depends. It's not really being specific.
Right. Yeah. It's kind of hard to say, but I think that's a good point though, that I could buy the Binax one and then just take both tests. I think if they're both positive, I feel pretty confident I have the virus. If one's positive, one's negative, maybe inconclusive, maybe I'll go buy a new one or I don't know, something.
If they're because it shows that only, 62 had the virus, or what was it? Read that right? Yeah,
68.
had the virus, but it said 38. Or what am I looking at? Am I reading this wrong? That didn't.
It was those that tested positive, 62% actually had the virus, and then 38% didn't even have the virus, but they tested positive.
Yeah, exactly.
Yeah. So I think for this part, number two, I would say either answer is correct, or it's fine as long as you give a good reason, like was said, depends who's paying for it, or also I could just buy the Binax one and there's two of them in the thing and I can do both of them and feel pretty confident if both test results are the same, either both negative or both positive. But if you think, well, I just rather pay a little more and be more accurate, yeah, I think number two, you write either way, and I think it's fine. I'm okay with that. Does anybody have any questions on that second, either the table we did, the numbers, the values, or the answer to number two, or the probability?
So I also added that the US Post Office gives them out for free, so many per
Mhm.
house.
Yeah, I can't remember which one do they give out. Do they give out one of these ones?
I don't know, yeah, but they give out
Huh.
like per household. I
Yeah.
don't know what it is, but
Okay.
I'm like, so I put plus the USPS gives it out for free. So
Mhm. That's, yeah, I think that's a good point.
tests, they all work differently on everybody. How do you know you're actually doing it correctly? Are you,
Oh, Yeah,
rubbing your nose in it so long? Are you, dipping
you're
it
right.
in? I mean, I don't know.
Schools, yeah, like Irene said, schools give them out for free. I don't know how. I wonder if the schools give them the same brand as the post
No,
office.
the schools give them rapid tests or else you have to go home because they don't want you there.
Oh, right. That's good. That makes me feel a lot better about it. I would like that.
It's at the schools that I have been at for years. When that was going on, they give the kids rapidly.
Yeah.
Parents didn't have to pay for it.
So there's this last page, there's kind of a little bit more information to it. So we'll kind of maybe just go over this one as a group. But it says now there's a antigen testing example. Okay, this one now it's saying though, what about those that don't have any symptoms? What about them, and how does that affect all this same talk? So it says, suppose that the prevalence of asymptomatic cases. So now I think we're just focusing on those that are asymptomatic. But if you have the virus, but you have no symptoms at all in a particular region, is 40%. So in other words, people who have COVID, but are not experiencing any symptoms, and then that the antigen test being used is in that region is Illume. Is that how you say that? I don't know. Is that French or something fancy? Illume rapid test, which is $32 at Target for one test. And at least it's cheaper than the second page that we saw, but more expensive than the first one, huh? This test has a false positive rate of 9% for those who have no symptoms. So the false positive, that's not too bad. I think, what was the first one? The Binax one was 15.4, right? Is that right? Yeah. And then the false negative rate is 4%, which is higher than the Binax one, which had 1.5%. So it's actually not bad if you think about it. People that don't have any symptoms, there's no, I don't know, it sounds gross, but you don't have a runny nose. So then you swab your nose. I don't know. It's pretty good, I guess. 9% is all. Those percentages aren't too bad. So what's the probability that no symptoms are present here?
I put 400.
Yeah, let's see. The prevalence of asymptomatic cases is 40%. So 0.4. Would your probability 0.40 or 0.4? I guess as a probability, we'll use that the numbers in the table. And then the probability that there's a positive test result, given that this person has no antigens, which percentage does that have to do with, the 9 or the 4?
The 9%.
Yeah, right. And then so as a decimal 0.09. Okay. And then the probability that there's a negative test result, given that this person does have antigens. So this person is infected, but their test result said they're negative. That's a false negative. So that would be the 4%.
So 0.04.
Yeah, nice. All right. Sounds good. I think, yeah, that was just kind of the building blocks to get to the values in the table. They want to know if someone in this region had no symptoms but tested positive using this test, what is the probability that they do have COVID-19? So in other words, what is the value of the probability that antigens are present given that they have a positive test result? That's interesting. Huh?
Let's see. Well, we have to fill out the thing, right?
Yeah. So I think the question here is still the answer that goes in here.
Yeah.
The
A
numerator.
16 for the negative, yes. If I did it
Yeah.
correctly.
So
And
still
then
gets the-
16 minus 400
Yeah,
is
you're right.
384. So that's what it is.
Mhm. Probably the first one you want to fill in is the same place, the place that we put, we was 20% of 1,000 in the first two problems, but this one now they're saying 40% have this no symptoms. So this one, oh, dang it. Did I forget to put, there we go. This one here, 40%, 0.4 times 1,000. 40% of those 1,000 had no symptoms, but they were positive for it. So 0.4 times 1,000 would be 400. Okay. All right. And then the remainder of those 1,000 should have no antigens, I guess. Ah, what the heck? Sorry, my computer's being crazy. Okay. So the second one here, kind of similar steps to the last one, but now it's 1,000 minus 400 instead of 200. Okay, so 600 of these 1,000 didn't have, didn't have the virus. Okay, that's good. And then let's see, where are we? Of those 400, how many had a false negative, and how many of those 600 had a false positive? I guess we could fill in either first, but really we're interested in this value, so maybe we should focus on this guy next. So that's a false negative because they're in the row of I do have the virus, but they're in the column of I got a negative COVID test. So it should be the false negative number, which was it 0.4? Yeah. Oh, sorry, 0.04, 4%.
Yeah.
Yeah, times the 400 people that were infected with the virus. 4% of those infected, they didn't have any symptoms, but they tested negative. Let's see, that would be, is it 16? I think 16 people.
Yeah. That's what I got.
Okay, that's good. Out of 1,000, I guess that's pretty good. So then how about the fourth place, or the fourth empty box? This one, how would you find that guy? That's a good.
Which one? The
Uh,
bottom
the one we labeled 4 here, I guess the box we're interested in for this problem.
384.
Yeah, nice. You take the 400 people that were infected with no symptoms, and you subtract those that got a negative test result. The rest must have gotten a positive test result. 384. Yeah. So that guy would be 384. So we already, I mean, by now this is our third time. We know that that's going to be the numerator in our probability we're interested in. So I already know. I mean, you could do it at the end, but I know that we want the probability that someone got a positive test result given that. Oh no, sorry. The probability that someone actually had COVID given that they got a positive test result. But the denominator is going to be this number, so I need to figure that out. But I think first I need to figure out here, this box is going to be where the false positives come from. The false positives, it said that it was, what was the percentage? 9%, right?
9%, and then times 600, I got 54.
Nice. Okay, nice. 9% of 600, you go 0.09 times 600, and I think you're right, 54. Oh, 54 would be the guy. The 54 people got a false positive. The test was positive, but they actually didn't have the virus. That's a bummer. They quarantined for 10 days and go crazy for no reason, but hey, what are you gonna do? I guess it's better than the other way around. You're actually sick and you're just running around coughing on people. You didn't know it. I don't know. And then every topic in statistics, I swear the examples they do, they're either really controversial, like the whole COVID thing, everybody's very controversial about it, and then or it's something that's really a bummer. It's really sad. Either way, I don't really like talking about them. It bums me out. Okay, and then the sixth thing, we can fill this guy in now because it's just the difference between the number to its right and the number to its left. It's 600 people.
6.
Yeah, okay. The 600 people did not have the virus. 54 of those that did not have the virus tested positive. The rest must have tested negative. 46. Okay. 46. And then from there, yeah, this is the easy part. I just add the numbers vertically and I get the bottom guys. And I guess now I could have, I think before I said, oh, we got the number we need so we can stop. But that was when I forgot there was it was a whole probability thing. I need the denominator of my probability. It should be 384 plus 54 vertically. That'd be 438, I think.
Yeah.
I added that right. Okay. And then I don't really need the last number, but I mean, I feel like I'm almost there. I might as well just finish it, right?
562.
Yeah. I mean, we didn't need it, but hey, it's just like a freebie. It's low hanging fruit. I might as well do it. So the question was, how many people out of those that tested positive, how many actually had the virus? So it'd be kind of the same percentage they're asking for, 384 over 438.
So I rounded it to 88%.
Nice. Okay. Thank you. 80. So 0.88 would be 88%.
Well, it was 0.876, so I just rounded it
Ah.
to 8.
Good point. Yeah, because if someone did it on their calculator, they'd say, "Oh wait, I didn't get 0.88." They get
Yeah.
yeah, and then say, "Wait, no, that's right. It's just rounded. That's all." Yeah, good thinking. Okay, because I feel like the more times we did it, the easier it got. Hopefully, I guess that's the idea.
Unless you turn the numbers around, then they'll probably get it wrong.
Right. Yeah, I think the part of it is I have to really think about what does false negative mean? Is that someone that has the virus and they got a negative test result, or is that the other way? If I can keep that straight in my head, this is a little easier. And then
Yeah, exactly. That's why I said you've been keeping them the same. I feel like if you moved them around,
yeah,
I'd have to look at my notes again.
I think you're right. Yeah.
At least for me, I don't know,
Yeah.
because I was so used to you giving them this way. So I'd probably mess them up.
Right. That makes sense. So this last question on this worksheet, this is the last thing we're going to talk about, but it's kind of a hard question to answer because it says, okay, would you recommend this test, this one that we just talked about in this problem, to people in your community who have no COVID-19 symptoms? Why or why not? So I think in this one, we were focused on people that did not have any symptoms. And of those that did not have any symptoms, if you tested positive, you actually have the virus 88% of the time, which is pretty good. That's a pretty good
So
number.
you had the virus?
Yeah, even if they had no symptoms. So these people had no symptoms. If of those that tested positive, of those ones that tested positive, 88% actually did have the virus. The rest didn't have the virus. So would you recommend this test to someone that says, okay, I don't have any symptoms, but I just want to check, do I have the virus or not? What do you think? Would you say yes or no?
I think that's controversial, and I don't want to say the wrong thing, but
That's
I
awesome.
work with kids and I would get sick all the time.
Mm.
And I feel like it just makes your body stronger. I'm not saying that it doesn't affect people because I've had family members die, but why would you really want to know something? Because when it's your time to go, it's going to be your time to go. So if you don't have any symptoms, why would you want to know? You feel fine.
Right. And it's hard to know.
And
Yeah.
that's like everybody's own opinion. And that's just me because I'm a happy, positive person. And I wouldn't want to know if I'm feeling fine. Like,
Yeah. No, okay, well, I guess I was thinking about this. If someone doesn't even have any symptoms, what would even make you want to test? What would make you
that's
think?
what I'm saying. Yeah.
I guess
I don't know.
it's
It's
those.
weird.
To keep other people safe. I mean,
Yeah.
I mean, and I have old parents. I mean, it's just better to know than not know if you have the money to do the
Yeah,
test.
that's why I said it's controversial. I think it depends on each person
Yeah. And
because how would you go check? It's like with everything else, you'd be doing that every day.
Yeah, because
I don't-
my
I
husband, when my husband got it, all he got was just like a random headache, which, I'll get natural headaches. And being that I have 2 sickling children, I totally would recommend something that's a little bit more accurate for my kids' safety.
Exactly.
yeah.
You don't really know too. You could be taking a test and it says it's negative, and then you had to wait like a week before. Now they
Yeah.
have ones, but they're not all 100% accurate.
Right. I think this situation here in page 3, it could be good for someone like, I don't know if you ever had someone say, oh, you know how I was hanging out with you last weekend? I have COVID
Got
now.
me sick. Yeah.
Yeah, so you're like, wait, I was hanging around you, but I don't feel any symptoms. Yeah, it's probably the type of person that would probably test themselves, even if they don't have symptoms.
See, that's why I said I've always worked with kids my whole life, like babies to adults. And I think it's made my immune system longer, and I've never tested positive ever.
Nice.
I've had to be tested. You know what I mean? Working.
Yeah.
And I've been around kids that have had it.
Mm-hmm.
And like I said, and I've never tested positive with their rapid test ever. We're knock on wood. But I know that it's bad. I'm not saying that it's not bad, but I wouldn't go out of my way to get tested. I just stay away from people,
Yeah, I think in this one it's hard to say either way because this is the result for this one. This is the only page we've talked about people that are asymptomatic. The other pages they didn't say on page 1 and page 2 they didn't say, oh, the people that took this test have symptoms or they don't have symptoms. So I don't, it's hard to compare it. 88% seems good, but we have nothing to compare it to because these are the only people that we've focused on that have no symptoms. So I mean, it's up to you. I think if you say no, if you have a good argument, that's fine. Yeah, just give a reason, I guess. So yes or no, either way. I think 88% is pretty good, if I'm being honest. But like I said, that percentage seems better than the other pages, but they don't say whether these people had symptoms or not. But
Like I
88%,
said, it's kind of controversial. It really depends on, which you do.
yeah,
That I'm tested every day, but I wouldn't go out of my way to get tested just to go hang out with,
yeah. But
my own friends,
I think in this
unless
one,
it made them feel uncomfortable. And then
I think in this one, I would say yes is probably a good answer because this one says the probability is 88%. That's better than the answer on page 1 and on page 2. And those ones are full of people that may or may not have had symptoms. So I think this is probably pretty good. It's better in this test for people that don't have symptoms, even better than the ones that did have symptoms. You would think those do have better results because they have, oh no, it's so gross, but like runny nose and all that stuff that might make it more obvious they have the antigens and stuff. Yeah. Does that make sense?
I think that's why my girls' school has got so adamant about it, where they give out free COVID tests so you can do it at home. And they even give you like a website where you have to scan it and you have to report it to them that way. That if the child has a headache or whatsoever, you scan it, you submit it to the teacher. And if it's positive, negative, whatever, they know immediately.
That's awesome. I hope all schools are doing that. That seems like a really smart way to do it. It makes it easy on the parent, it makes it easy on the kid, and they're not coming to school.
And it's free. They give them like 3-4 tests to do the siblings at home as well if they know they have siblings.
Wow, that's really nice. I mean, it's good for the other kids at school so they don't get infected, and it's good for the parents because they don't have to pay for a test. Yeah, that's awesome. That's a good way to do it. Yeah, how do you feel like number 4? Any people think no, it's not a good, or you would not recommend it to someone's asymptomatic, or do you think yes is a good answer?
I think
and
yes.
how long is this
Answer.
test? Do you know what I
Yeah.
mean? Like, are you going in to have to make an appointment? Is this a rapid thing? It's like,
Oh
if
yeah,
you're-
I
I don't know.
think these are, I guess they didn't really say it, but I guess we're assuming these are people that want to take a test and they have no symptoms and they're saying, I want to take a test, but I don't know which brand to buy. Then I think,
Yeah.
so I think the answer is yes. And yeah, they're not really saying that, but I think we're assuming these people want to take some tests, but they don't know which one to buy. Yeah.
These
Like,
going off the number on this one, and we did
Yeah.
it on the other one. It just depends. Like I said, it's opinion, or you can go off the numbers.
yeah, I think you're right.